Hey, it's Mr. Lum, and I'm going to be your Science 9 teacher, and we're going to be starting off the course with some chemistry. So what you should have is a copy of the guided notes, and one of the first things that it says is what is matter. So matter is something that has mass and volume. Now, not my best definition ever, but mass is the amount of matter, which not the greatest definition, but it's on Earth, it kind of means like if something has weight to it, and volume is the amount of space it takes up. Okay, so if something has weight to it on Earth, um, and if it takes up space, then we can call it matter. Uh, now, when I say mass is has to have weight, and if it's in outer space, it's weightless, but it still has mass, right? Because if you threw that object, it would still have inertia, which means that it can impart force onto another thing if it hit it, and so we'd still say that has mass. So properties of matter is that it'll have three very common states on Earth: solid, liquid, or gas. There is a fourth state of matter, which is plasma, but we don't see that very often on Earth. In outer space, we actually see plasma a lot in the universe. So our sun, often people will call our sun a ball of gas. Well, technically, it's a ball of plasma. Um, and So another property of matter is that it'll have a certain amount of conductivity. Conductivity is how fast electricity or heat moves through it. So some things are very conductive, like metals. They conduct electricity and heat very well. And some things aren't very conductive, like plastic or rubber. Electricity and heat doesn't go through it very well. Now, the next one is that another property of matter is that since matter has a solid, liquid, or gas state, it can switch between those different states, and it'll switch at very specific temperatures, and we call those temperatures boiling points or melting points. Now, everything is going to have a different boiling point and melting point, and that depends on the material. But these are the properties of matter. Now, hopefully from grade 8, you remember the kinetic molecular theory. And the kinetic molecular theory states that all matter is made up of tiny particles, and there are empty spaces between those particles. And the particles are always moving, with a very few exceptions. And more energy the particle has, the faster they're going to move and the further apart they're going to get. So, for example, solids here, solids are barely going to be just vibrating. They are moving. It doesn't look like they're moving, but they are moving, but they're just kind of vibrating away. Okay. Liquids are going to be moving a little bit more, and gases are going to be moving a lot. Now, there is a certain temperature in which particles are not moving. We typically call that absolute zero. And, or in other words, the coldest something can get is minus 273 degrees Celsius. Can't get colder than that, because temperature is actually just a measurement of how fast particles are moving. And if particles stop moving at minus 273, well, there's nothing below that. Okay. Oh, a little formatting error there. So you should have a copy of this thing right here. Solids have a fixed shape. So solids, and you can fill in this, they have a fixed shape. That means this solid, which is like this is two-dimensional, but if it was three-dimensional, it'd be like a cube. This solid right here That's the shape of it. Okay. Now, for this liquid right here, it doesn't have a fixed shape. It takes the shape of the container that it's in. So it takes the shape of this container right here. If it was placed in a glass, a round glass, it would take the shape of that round glass. So what we'd say is that the shape of liquid is not fixed. Okay, and same thing for gases. Right now the gas is in a box, so it takes the shape of the box. If you put the gas in a balloon, it'll take the shape of a balloon, and so on. So this one is not fixed. Now the volume of a solid. The volume of the solid is also a fixed volume. If this was occupying, say, 10 cubic inches, it'll be occupying 10 cubic inches. Doesn't matter where you place that object. So we say it has a fixed volume. Now, for liquids, even though it doesn't have a fixed shape, right, it does have a fixed volume. So if this was, say, 100 milliliters, it will be 100 milliliters if you place it in this box here. It'll be 100 milliliters if you place it in a glass or a beaker. So what we say is that it has a fixed volume. Now for gases, they're not fixed. If you placed it and you compressed the gas in a tank, it'll occupy a smaller volume. If you release that gas into a larger area, it'll occupy that larger area. So it doesn't have a fixed volume. Now, the spaces between solids, there's very little space in between solids. The space between liquids, a little bit more space. And gases, there's lots of space in between those particles. Now, in solids, the particles are kind of just vibrating away there. And in liquids, particles are moving. And here, the particles are also moving, and they're moving a lot. Now, like we talked about before, is that solids and liquids and gases can change states. They can, solids can change into liquids. The solids change into liquids by melting. Now, and liquids can change into gases by boiling. So a change of state is when enough energy is added to a solid, it changes to a liquid. And when enough energy is added to a liquid, it can become a gas. Okay? And we are very familiar, hopefully, with the changes of states of water, H2O. And we know that when it goes from solid to liquid, that'll happen at 0 degrees Celsius. And when it goes from liquid to gas, that'll happen at 100 degrees Celsius. So it has to have enough energy for it to change states. Now, some chemicals have special properties in which they skip a step. Like sometimes you have some chemicals that'll go from solid straight to gas. And this is called sublimation. In sublimation, solids change straight into gas. Now, there's not a lot of chemicals that will do this at room temperature, but the one that comes to mind is dry ice. So dry ice, it's not made out of water at all. It's when you take carbon dioxide, CO2, and you have a chunk of CO2, and if you've ever seen dry ice, if you have a chunk of CO2, it will change from solid CO2 and just go straight into gas. And the opposite of that, when you go from gas straight into a solid, it's called deposition. Now, again, I can only think of two chemicals that do this at room temperature, and that is carbon dioxide. And the other one that's quite surprising for people is caffeine. Caffeine doesn't have a liquid state. So a lot of people think, whoa, caffeine does have a liquid state. Caffeine is in coffee, it's in tea, it's in Coca-Cola, and it's in energy drinks. And those are all liquid. And I want to make sure that we understand that caffeine actually doesn't have a liquid state. That is not a liquid state, that is dissolved. Okay, so caffeine is dissolved, so like say take an energy drink. Caffeine is dissolved in the water that is the energy drink. Okay, kind of like when you put sugar into water, it dissolves. Melting sugar, making liquid sugar, is very different than having dissolved sugar. Melting sugar, you put sugar in a pot and you just crank up the heat and it'll start to slowly melt and kind of caramelize, and that is when you're making liquid sugar. But caffeine doesn't actually have a liquid state at room temperature. You can make it if you put it under a lot of pressure in a special pressurized tank. You can get a liquid state of caffeine, but under normal circumstances, caffeine will not have a liquid state. Okay, so a couple more definitions we're going to run through, and that is an element. An element is a pure substance, and elements can be found on the periodic table. So anything that you see on the periodic table is considered an element. Now, a substance that is made up of two or more atoms that have chemically combined is called a compound. And there's a whole bunch of different types of compounds. Now, an atom is an element, but an atom is when you have one particle of an element, and that can be broken down into just one thing. So, for example, here's an example of water, H2O. So, H2O, which we know is water, is made up of two hydrogen atoms and then one oxygen atom. Okay? Now, this whole thing right here, it has three atoms total, two hydrogen and one oxygen. It has two different elements, hydrogen and oxygen, but this whole thing is a compound. That whole thing is a compound, okay? Because it is two or more atoms that have combined. Okay, now we can see all of these different elements on the periodic table right here, and yeah. And here again is oxygen, and we have hydrogen right there. Now, a pure substance is when there is only one type of particle present. And there's two different types of pure substances. An element, pure substance, where it's only one type of atom. And so for here, I have gold, like these are my representations of gold. Now gold is an element, gold is on the periodic table, and it is one type of atom. Now, a pure substance can also be something like this. This is water, and each one of these things is a water particle or a water molecule or compound. And there's only one particle there, one type of compound, but we still call that a pure substance. Now, a mixture is when you have two or more substances are present together. So, for example, here is, say, water down here, and let's pretend that this thing right up here is, I don't know, some type of compound like magnesium. Okay, so we have a pure substance, which is an element. We have another pure substance, but this one's a compound. And if we put these together, then that will turn into a mixture. A mixture is two types of particles that are present. So, for example, if you had something like coffee, for example, coffee is a mixture. Even though it looks pretty uniform or looks the same throughout, it'll have water in it, it'll have caffeine in it, it'll have tannins, which is like gives it that black color, and then I'll have a whole bunch of different types of chemicals in there for its flavor. But it's a mixture. So there's two major types of mixtures that are present, mechanical mixtures and solutions. So this got cut off a little bit, but a mechanical mixture is you can see more than one thing present in the mixture, and you could hand separate it if you really wanted to. So here's a mechanical mixture. This is a picture of sand, and sand is made up of a whole bunch of different types of rocks. Like we see some these clear ones right like there. It's probably like silicon dioxide. Some of these white ones right here, which might be like some calcium carbonate, and then we see some darker kind of black rocks, which I'm not sure what that would be, and some of these other ones right here. But you can, like, all of that kind of stuff is a mechanical mixture. You can see more than one thing present, so we call it a mechanical mixture. Now, a solution is you cannot see more than one thing. Here, let's rewrite that. More than one thing present. It looks like it's just one thing. So grape juice. Now, it looks like there's just one thing. Okay, you cannot see all the other things in there, but you know that grape juice contains water, it contains sugar, and then it contains like other tannins from the grapes, and it contains a bunch of esters from the grapes as well. So there's lots of different things that are in grape juice, but when you look at it visually, you can only see one thing. And so, yeah. So even if you took, like, say, coffee, and you had black coffee, it looks like it's one thing, it's a solution. But then say you add milk to it and stir it up, it still looks like it's one thing, it's a solution. And say if you threw in a couple of scoops of sugar and mix it up, it still looks like it's just one thing. And so therefore it's still a solution. But it is a mixture.